Hello, kids. Welcome to 6.2. Hope the first one went well, and maybe by the time you watch this, we would have even met once. For this one, this is the natural base e. This is an exponential lesson as well. It deals with a different number. This e is referred to as Euler's number, and on the assignment sheet right here, I made a link for you to go watch. Okay, so there's a link on the assignment sheet that kind of explains what the E is. I'm not going to take a lot of time now. I'm just going to jump kind of into what we're going to be doing here. But E is a number. It's similar to pi. It's an irrational number that goes on forever and ever. It's called the natural base. It shows up a lot in just nature and science, and it's the natural number for exponential growth. So E is on your calculator. If you look right above the LN button that you see an e to the x. So if I go second and press that, if I go just to the first power, you see that e is 2.718281828. It looks like it repeats, but it does not. The numbers after that last 8 are different. So about 2.718 is the approximation for e. There's lots of different formulas, lots of different ways to find it. Again, all the answers to the student journal are in the Google Drive folder that I sent to you. Okay, so what we need to know here is we have the natural base e. Here you can see it differs after that last 8, 4, 6. It is irrational. It goes on forever, and it's on the same like-mindedness of pi. Other than like pi has a geometric relationship, e doesn't really have that. So when we have a times e to the rx, that is the natural base exponential function. So e, that's what they're referring to as a base. It's a base number. So if I have 2 to the x, 2 is the base. So the natural base is when you have e, this 2.718 number. Okay, so a, that is your starting amount. Again, similar to what we had on the previous lesson. R is your growth factor. If r is greater than 0, then you have a growth. If r is less than 0, that means if it's negative, you have a decay. So if your rate is positive, it's going to be a growth factor. If it's negative, it's going to be a decay factor. So your parent functions here, y equals e to the x. Again, 0, 1 is your y-intercept, because if x is 0, then anything to the 0 power is 1. Exponential decay is if you have e to the negative x. And there's 2 parts to your assignment. Second part is mostly graphing, which you can use Desmos to help you with that. The first part is just reviewing your properties of exponents, really is what it is. So we'll go through a few of them here, and then you're going to have some on there to do as well. This formula here, this is your continuously compounded interest. So we had the compound interest formula on the previous lesson, which is 1 plus r over n to the nt. And the video that I have the link to, that will tell you what happens as n gets more and more and more. So you get this one, a equals p e to the rt. P is, again, your principal. R is the annual interest rate expressed as a decimal. So if you have $5,000, and you're investing it at a rate of 5.2% for, let's do 8 years, your amount would be 5,000 times e to the 0.052 times 8. So 5,000 times e to the 0.052 times 8. Close that, and you'd have 7579.43. That's what you have. Okay? So remember your properties of exponents. If I have x to the a times x to the b, that is x to the a plus b. X to the a over x to the b is x to the a minus b. X to the a to the b is x to the a times b. And the bth root of x to the a is x to the a over b. Okay, the bth root. I like the bth root. Also, x to the opposite of a is the reciprocal, 1 over x to the a. So those properties right there. So this falls into the first one, e to the negative 9 times e to the 12. That would be e to the negative 9 plus 12, so that's e to the third. And you just leave it like that. Number 2, you have two parts. You have to reduce 25 over 35, and then you have e squared over e to the 7th. So 25 over 35, you divide those by 5, you get 5 over 7. And then e to the 2 minus 7. So that part right there is e to the negative 5th. That tells you the answer should be on bottom. So 5 over 7 e to the 5th. So only positive exponents when you're done. Can't have negative exponents when you're done. So just think of it, there's 7 e's on bottom, there's 2 on top. So 7 minus 2 is 5, it goes on the bottom. Okay. So, sorry. Here we have 2 e to the negative 3x to the 5th. So you take 2 to the 5th, you have to take e to the negative 3x to the 5th, and then we have times 2 times e to the x plus 1. So 2 to the 5th, e to the negative 3x. So 2 to the 5th times e, multiply those to the negative 15x, times 2 to the 1st times e to the x plus 1. So you see you have a common base of the 2's. So we can take 2 to the 5 plus 1. And then we have a common base of the e's. So e to the negative 15x plus x plus 1. Because you're multiplying them, you're going to add your exponents there. So you get 2 to the 6th, I believe that's 64, and e to the negative 14x plus 1. So you can put the 64 there. Yes, it's 64, but I'm running out of room there. So 64, e to the negative 14x plus 1. Okay, last one, 4th root of 16 e to the 24x. That's going to be the 4th root of 16 times the 4th root of e to the 24x. Okay, this property is going to come into play right there. 4th root of 16 is 2, and this is e to the 24x divided by 4. Power over root. Power over root. So we get 2e to the 6x for that final answer. 24 divided by 4. Okay. So you have several of those examples. Where was that? Nope, I don't have it. Okay. And again, properties of exponents are what you're going to apply to that. If you need help with those properties, just YouTube or Google properties of exponents, and you can do it. Or go to Khan Academy. They have lots of examples with that. Tell whether the function represents exponential growth. Remember that is r is greater than 0, or exponential decay. R is less than 0, positives and negatives. Then graph the function. You can use Desmos for that. So 5, you see the negative sign right there. That makes it a decay. 6, you see a positive sign. That's growth. It's a positive 4. 0.25, even though it's less than 1, with a continuous growth, that is still positive, so that is a growth. Negative 3, that's negative, so that is decay. You can use Desmos to help you graph it for your assignments. Okay, domain and ranges stay the same. We won't have any of those questions. Remember, this function has been translated 4 units down, so your range would be y is greater than 4. This one's been shifted 3 units left, so your range would be y is greater than 0, and y is greater than 5. This first one should be negative 4. May have missed that on the last video. Negative 4 because it's 4 units down. 5 because it's 5 units up. Okay, and all of those are growths. Okay, let's look at these. Population of Evans City is currently 48,500, declining at a rate of 2.5% each year. This is your formula. Looks very similar to the continuous growth formula. They just put different variables in there a little bit. PC is the current population, so that would be this. PT is the population after T years, and R is the decimal rate. So decimal, that'd be 0.025. Predict the population in 25 years, so there's your T. So the population after 25 years is going to be 48,500 times e to the 0.025 times 25. Handy dandy calculator. 48,500 times e raised to the 0.025 times 25. Oh, wait. Okay, so I got this answer, and I'm like, wait a minute, that's more. It has to be declining. It has to be dropping. So that needs to be a negative in there. So negative 0.025. It is declining, so we need a negative. I was kind of thinking our last one, when I had a 0.025, that it declined, but it has to be negative. So let's try that again. Insert the negative, and we get 25,960, around there. So probably around 26,000. Okay, don't round to a decimal point. You aren't going to have 0.2 part of a person. That's not nice. Okay, parents will need to need 25,000, more like 40,000, in 10 years, 50,000, to pay for your brother's college tuition. They can invest in an account with an interest rate of 9.8% that compounds continuously. Okay, it's not compounded monthly or quarterly or daily. It's compounded continuously, so that means we're using A equals P e to the RT. How much should your parents invest today in order to have your brother's full tuition available in 10 years? So this is what we need. We want $25,000. We need to know how much to invest, but we have E raised to the 0.098 times 10. Okay, and we need that P. So we have two functions we have here. We're going to graph y equals 25,000. And we're going to graph y equals x times e to the 0.098 times 10. Those are two equations, good old Desmos. Okay. And then we're going to do a lot of zooming again. Why don't you like that? Alright, guess we need a function in there first. 25,000. There it is. Oh, we don't have to have a graph of this, but that does not look right. 19,000 available in 10 years. 0.098. It helps if I write the right numbers, doesn't it? Okay, so that's one way to do it. The other, just thought of this, is you have this function here. If you take 25,000 and divide it by e to the 0.098 times 10, that should equal what the p is. So if you just take this and divide it over, you can do that. That would be a lot easier. Okay, there's your, oops, let me go back. You weren't seeing that, were you? Sorry. Okay, so if you take this, you're solving for p, just take this value, that's a number, divide it over, so 25,000 divided by e to the 0.098 times 10, that's going to give you a p-value. You get 93.82 both ways. So you need $9,382.78 to invest. Okay, and then after 10 years, you'll have your 25,000. Okay, word problems are minimum on this one. Hopefully this assignment goes okay for you. I know it's something new, and let me know what questions you have. Good luck. Stay Bluebird strong, and we'll see you next time. See you kids.